Okay, we're beginning Unit 3 today, and this first section, 3-1, we're talking about complex numbers. And so we begin by looking at a little bit of background information about I, something that you're familiar with also from Algebra 2, but just kind of to reiterate here. We start off by talking about the fact that some quadratic equations, they don't have any real solutions. And so there's an example that's given here. And so it goes on to kind of talk about there is no real number x that can be squared to produce -1. And so mathematicians have created an expanded number system using the imaginary unit I. And I is defined to be equal to the square root of -1. All right? And then, of course, that would make I squared equal to -1. All right, and so by combining real numbers with this imaginary number, you get a system of complex numbers, right? And the standard form for complex numbers would be a plus bi, right? And so here's an example. If you combine these, so the square root of -9 would be the square root of 3 times the square root of -1, right? And so they've simplified that here, -5, and then so square root of -1 turns into an I, and then write it in standard form with the real component first, then the imaginary component second, and then you've got yourself a complex number here. All right? And so again, here's the standard form. And you've got a real component, you've got an imaginary component, and together they form a complex number. There are some properties that hold true also in the complex number system, namely the associative property, commutative, and distributive property. All of those work for complex numbers. And also here we have the powers of I. And so of course, I to the first power is I squared. That would be square root of -1 times square root of -1, which is -1. And then I to the third power, right, would be I to the first times I squared, which is I times -1, which is -I. And then I to the fourth could be I squared times I squared. -1 times -1 is +1. And then beyond that, they just repeat. So I to the fifth would be I to the sixth, -1, I to the seventh, -I, and so on. It just repeats every 4 powers. Okay? All right. So exactly what are we going to be asked to do in this section? So what we're going to be, one of the types of problems we're going to be asked to do is to perform addition and subtraction with complex numbers. So here I have 2 complex numbers added together. This should be no trouble at all. You simply combine the real component and combine the imaginary component, and you've got the answer. So 3 plus 2, that's 5. -I plus 3i is plus 2i, and you've got yourself the answer there. All right? So next type of problem, we're going to practice multiplying complex numbers together. And so here I can use the distributive property, which is one of those properties that was listed on the other side of the sheet, saying that it's good to be able to do those in the complex number system. You can use the distributive property. So we'll go ahead and multiply this out. So it works the same way. This 2 will multiply times every term on the other side, and then this -I will multiply times every term on the other side. So I've got 2 times 4, so that'll give me 8. And so the next thing we come up with is 2 times 3i. 2 times 3i, so that would be plus 6i. Now I'm going to slide over and take this -I and multiply it. -I times 4 is -4i. And now I've got negative times a positive, which is a negative. And then I've got I times 3i, which is 3i squared. Okay, so continuing to simplify here, we can talk about this 8, and at the same time we need to take a look at this I squared. Well, remember from your other page, what's I squared? Well, I squared is -1. And so I'm going to take this I squared and I'm going to change that to -1. So that means negative 3 times negative 1, that's going to be a positive 3. And then positive 3 plus 8 is going to be 11. All right. So there's my real component, 6i minus 4i, and that's going to be plus 2i. And we're done with that particular problem. All right. Okay, so next, another problem we're going to practice multiplying out. 3 times 3, that will give me 9. And so 3 times negative 2i, that's going to be negative 6i. And slide over now, 2i times 3, right? That's going to be plus 2i. And here, positive times a negative, negative. 2 times 2 is 4. I times I squared. And let's see if we can't combine some things together. And I wrote this down wrong, by the way. I'm going to switch that now because 2 times 3 is 6i. Right there is what it should have been. All right, so those will disappear in the middle. And here, remember, I squared is negative 1. So negative 1 times negative 4 is going to be positive 4. And if I add that to 9, then my answer here is going to be 13. Okay? So we're just multiplying these out and then simplifying it. All right. Next type of operation we're going to look at is division. So we're going to talk about how to divide complex numbers. And so the description that's given to us here is you can multiply the numerator and denominator by the complex conjugate of the denominator. And so what that does for you is it actually causes some simplification to happen so that the resulting answer can be much more simple. And so this term conjugate, okay, it kind of means where you just change the second term, the sign of the second term. Based on what's there. So let's actually do an example, because when you see all this together, then sometimes it can be difficult to kind of see what's happening, and it's much simpler to see what's going on when you actually do an example. So let's do that. All right, I want to divide these two complex numbers. All right, so again, up here they're telling us that we need to multiply the numerator and the denominator by the complex conjugate of the denominator. Okay, so let's write out our problem here. So this will be 2 plus 3i over 4 minus 2i. Okay, so I want to multiply the numerator and the denominator by the complex conjugate. Complex conjugate. All right, so the conjugate here would be, like for example, if the denominator is 4 minus 2i, the conjugate would be 4 plus 2i. All right, and it's called a complex conjugate because it's a complex number, right? And so whatever this two-term expression is, the conjugate would be formed by just changing the sign of that middle term from a minus to a plus. And remember, whatever I do to the bottom, I got to do the same thing, multiply the same thing by the top. So that's going to be plus 4 plus 2i here as well. And so remember, you're not changing your problem because this is just multiplying by 1, which won't change anything. That's why it's okay to do. And why do we do it? Because it's going to simplify things for us. All right, so let's see what that looks like. Okay, so from here now, when we're taking a look at this, we can multiply the top together. So 4 times 2, we have 8. And we've got now 2 times 2i. And so 2 times 2i would be plus 4i. Now I can slide over with this. So that'd be plus 12i. And now I can go 3i times 2i, which will be plus 6i squared. And that's the top. Let's do the bottom now. 4 times 4 is 16. Sign is plus. 4 times 2i is going to be 8i. Alright. And now sliding over here, negative times a positive is a negative. 2i times 4 is minus 8i, and negative times a positive is a negative, and then that's going to be negative 4i squared. Alright, so I'm just multiplying the two expressions out. Alright, so from here what we can do is we can take a look at the top and simplify that. Remember, I squared is going to be negative 1, and negative 1 times 6, negative 6, so 8 minus 6, that actually gives me 2. And so for the complex, or from the imaginary part, 12 plus 4, that's going to give me 16i. Okay. Now at the bottom of this thing, let's go ahead and take a look at the I squared. I squared is negative 1, right? So negative 4 times negative 1 is positive 4, and 16 plus 4, I'll go ahead and make that 20. And 8i minus 8i is gone, so I'm just left with this to simplify. And so in order to simplify this, I need to take a look and see if I can't divide this 20 into both of these expressions and make two separate fractions out of it. And so 2 over 20 would reduce to 1 over 10. My sign in the middle is going to be plus. And 16 over 20, that reduces to 4/5. 4 over 5i. Alright, so these are the type of things you'll be expected to do on your quiz. And so now you should have everything that you need to go and complete that.